So previously we went over 4.7 on antiderivatives. Went over that page, the basic definition and concept. Did a number of examples. So if you hadn't seen this, go ahead and look at those examples and try them. Then we went over initial condition questions. Here's two examples here. Okay, next we're going to get into the last part of this section, which is projectile motion. So let's take a look at that. So this idea of projectile motion basically is if you throw something up in the air, goes like this, and then it comes back down. Okay, so, and you have a direction like that. Or you could think of it as going straight up and then eventually turning around and going back down. Depending on how you define your axis and all that. So usually we write motion of something in terms of time and the letter S. So S of t is what we call the position of the object. S prime is instantaneous rate of change or velocity. So we call that v of t. So that's velocity. S double prime of t is v prime, change in velocity's acceleration. So that's a of t, or acceleration. So suppose a point P is moving on a coordinate line with acceleration a of t at time t. So with acceleration a of t at time t. So then if we look at the antiderivative of that, we're going to get you're going to get v. So what we have then, since a of t is equal to v prime of t, that means if you integrate a of t dt, that is the integral or antiderivative of v prime of t dt, which is v of t, of course, but then it's plus c, because we don't know what that initial condition is necessarily. And then similarly, the integral of v of t dt is the integral of of s of t, s prime of t dt, which is s of t plus an arbitrary constant as well. So let me show you this by example. It's pretty much the way we want to do this. Essentially, you are given, it's the same question as above, but we can think of this in terms of projectile motion to find the position vector. Okay, so let's look at this example. Here. Let me erase a couple things I didn't mean to have in there yet. Okay, so a stone is thrown vertically up in the air from a position of 144 feet above the ground with initial velocity of 96 feet per second. Disregard air resistance, okay. Find, and then here's your three things: distance above the ground after t seconds, the length of time that the stone rises, like how long it goes up and before it turns and comes back down, and when meaning time, and with what velocity the stone strikes the ground. So we have three different things to look at. So let's take a look at this question. So what's given in here are your initial conditions. So the 144 is initial position. So S of 0, their position at time 0 before it goes anywhere is 144 feet. So S of 0 is 144 feet. Okay, that's what I had highlighted before. That's your initial condition, or one of them. Then also, V of 0, the initial velocity is 96 feet per second. Okay, so this is 96 feet per second, is also your initial condition. Okay, now what we weren't given, but you can look it up, or we were kind of assumed, is the acceleration of gravity at the surface of the Earth at sea level is A of t is 32 feet per second squared. Excuse me. And in case you're wondering, that's 980 centimeters per second squared. So you would use either of those two depending on your units, or of course in feet. So that's what we start with. So A of t is equal to V prime of t. And it's always, when you talk about acceleration of gravity, you always have it negative, so downward. So A of t, which is V prime, is we always consider that negative 32 feet per second squared. So then now we integrate to get our position function and use initial conditions, just like above. So V of t is equal to the integral of V prime of t dt, which is acceleration. So that's the integral of negative 32 dt. Right? So that's all I'm placing in there. Is your A of t goes here, which is this. And it's just a constant, so you get t. So that's equal to negative 32t plus c. And because we have an initial condition given, we can solve for c. So V of 0 is equal to 0 plus c, which is equal to 96. So that implies, or actually you can say equivalent to c equals 96. Right, and that's because that would make sense. That's where you start. So then what we have is okay, so that's V of t. So S of t is the antiderivative of V of t dt. Which is so that's S prime, it's the antiderivative of S prime of t. I didn't write that up there last, or did I? That's right. dt. All right, so that equals what we had up there. So that's the antiderivative of negative 32t plus 96 dt. All right, so then you get that that's equal to negative 32t squared. Oops, oh, didn't do that right. That's going to be negative 16t squared plus, right, you add 1, you get 2 and divide and get 16. And then 96t plus your arbitrary constant d. But we're given s of 0 is equal to 144. So you can see you put in zeros. Those are both zeros. Those go to 0. And so d will be 144. Okay, so you get d is equal to 144. So therefore, your position function s of t is negative 16t squared plus 96t plus 144. And so your units here would be in feet. So t is time in seconds. And then if you put in this, you're going to get the feet like above the ground. So then let's answer the questions. Distance above the ground after t seconds. Well, that's this. This is A. That is the distance above the ground after t seconds. Okay, so then, oh, and we may want to graph this thing. Let me just give you a rough sketch what it might look like. So if you actually were to graph this, you're going to get basically a parabola. And did I solve for it? I actually did it later. Well, I don't want to go through the little details of it. Basically, you get a parabola that looks like this. And so you're starting up here at your 144. You can check this out. But you start there, 144. So we want to know, when does it hit? This would be the ground. Now, it obviously doesn't keep going, but your function would make it keep going. And you don't have negative time over here, but those are your domain restrictions. So the top is going to be here, right? So this derivative right here will give you where it maxes out, and then it starts to come down. So it's above the ground. You throw it up, and then it hits like that. So then what you do, what was the questions again? Let me make sure I go through this. So the length of time that the stone rises. Oh, so the stone rises from the initial spot to this position. So we'll call that like T1 or something. So we want to find that. So it rises up to here. Well, that's the apex of S. So isn't that S prime? Okay, so we want S prime of T to be 0. And think about it. When you throw a stone up or throw something up in the air, it goes up and then it stops just for a second and then comes back down. Okay, so we want to look at that height. We want to look when the velocity is also 0. Okay, so we'll look at that. So S prime, so this is B, would be negative 32t. It's actually up there, right? We actually solved for it already. But this is kind of verifying, I guess. Plus 96. Okay, and you solve for that. Oh, oops, set that equals 0 and solve. And what do you get? Something you can finish on your own. That's when t is equal to 3. Then it's 3 seconds. It takes 3 seconds to reach its apex, and then it's going to fall back to Earth. Okay, next, C hit the ground. What means means basically what? Well, that means that S of t has to be 0. So you're basically finding these intercepts here and here. Now, of course, the one on the left will not be meaningless in this case. Actually, I put an X there by habit, but that's actually time. So this is time. So certain things you kind of skipped over. You may want to go ahead and graph this thing. Just use a calculator. Not that one. Graph this. Use a calculator or something, a computer program. Just really quickly graph it. Get an idea what it does. Otherwise, you have to find the vertex, which you can. It's minus b over 2a, and then that's your vertex. You get an idea. You know the y-intercept is 144, right? Because you just put in 0, and you get 144. All right, so let's continue. So you're solving this for 0, negative 16t squared plus 96t plus 144 equal to 0. All right, so I would want you to solve that. You can try to factor. It's not going to work nicely with integers, and you end up getting, okay, and then I'm going to say quadratic formula is the easiest way to do it. You could complete the square. Not sure what else you could do, but you get 3 plus or minus 3 root 2. So we, of course, we omit the negative. So omit 3 minus 3 root 2, because that's less than 0. So no negative time is the idea. It would not make sense, despite the movies. Still doesn't make sense, really, to go negative time. It's like saying negative distance. Doesn't make sense. Whether you're going down or up, it's still a distance. Okay, so then it's 3 plus 3 root 2 would be the time. So what did it ask for, actually? It asked for velocity. When, okay, so when is that? So when or how long to hit the ground? That's that number. That's 3 plus 3 root 2, which is approximately, where is it? Approximately, I had it down there, I thought. I don't. Well, let's just do it real quick. Kind of curious, actually. So what is that calculation? So 2 root, 3 multiply, 3 add. So 7.2 seconds. 7.2 seconds. And then how fast is your velocity? So v of 3 plus 3 root 2 is going to be negative 96, I did this calculation earlier, root 2, so that's approximately negative 135, let's try that again, negative 135.76 feet per second. That's pretty fast. Wow. 135 feet per second. Well, I have to convert that to something I can really think about. But yeah, that's it. So that answer is B. That's how fast it is when it hits the ground. So you got to, again, picture this as a motion. Oops, I was trying to find a blue. So it goes out like, it's going like this, and then it's going to coming down, and then bam, hits the ground, makes an explosion at that velocity. Okay, so that's an application of initial condition questions and antiderivatives. All right, so then next we will get into the next chapter, which is on definite integrals and the meaning of the integral notation.